Hello everyone, myself Tejas Patel and I welcome you all in lecture number 4 of light reflection and refraction. Today we will discuss about the image formation by the concave mirror. So, image formation by the concave mirror. First we are going to study about the activity that is given in your textbook, that is activity number 10.3. So what we have to do in this, we are going to take one concave mirror like this. So this one is the concave mirror. Now we are going to put it on a stand. Now this mirror and stand we are going to put on a table like this. Okay. Now we are going to put this mirror in this way that this pole is lying on this table on this line. Okay. So here is P. So here also there will be P. Okay. Now what we are going to find out, that we are going to find out the approximate focal length of this concave mirror with the previous activity as we have seen in the previous lecture. So at the distance of the focal length, we are going to draw another line on the table that is parallel to this line, So this is the line that is representing the focal point and its focal length. Here P to F distance is the focal length. We are going to draw another parallel line that is parallel to this F line and it will indicate 2F distance. So this will be C. So P, F and C. These three are the point. Pole, focal point and C, center of curvature for the concave mirror. So I think all of you are clear about this, how we are going to perform this activity. Now what we are going to do, we are going to take one object. Suppose one candle is there. We are going to put this candle on the different locations between this C, F and P, and we are going to observe the image that is formed by this concave mirror on different locations. So with the help of this we can identify what is the size of the image, what is the type of the image, where the image is being located. So we are going to find out this all the things. So suppose we are going to put the candle on infinite distance like this. Okay. Now what we have to do, we are going to take a plain paper and we are moving around these surfaces and we have to observe that where this candle's image is formed. And whenever you are obtaining the candle's image, you have to stop your paper and you have to note down the size of the image, type of the image and location of the image. Now we are going to put that candle beyond C. So that is beyond C. Again the same activity is repeated. We are going to take a paper and we are moving around like this, and whenever the image is captured by this paper, so at that time we are going to stop that paper and note down the size, type of the image. We are going to put this candle on C. Same activity we are going to repeat. Now the candle's location is between C and F. Same activity we have to repeat. Candle's location is at F. Same activity we have to repeat, and whenever the candle is placed between F and P, the same activity we are going to repeat. And in all the 6 cases, as you can see, that infinite distance, beyond C, on C, between C and F, on F, and between F and P. For these 6 different locations, we are going to identify the image, its size and its type. So this is a simple activity that is shown by the image formation by concave mirror. So this is all the activity we have seen. Now images formation by concave mirror, we are going to see 6 cases turn by turn. So first case, as you can see the figure, the candle is at infinite distance. So what will happen, as you can see, as it is at infinite distance, so the rays coming from the candle, that will be parallel to this main line, that is principal line. So parallel to principal line, that will the reflected ray will pass from F. Okay, so position of the object is at infinity. So position of the image, as you can see that these two reflected rays will meet at point F. So as we can say that the position of the image is on F. As you can see the point size image, because both the arrows, both the rays are meeting at point F, and hence it will show you the point size image. and type is real and inverted. Why real and inverted? Because as you can see that the rays are actually meeting at point F, so real image will be formed, and inverted, as you can see, A point is its image is downward side and B point's image is in upward side, so inverted image will be formed. Second case, whenever the object AB is placed beyond C, as you can see that object AB is our candle, and as you can see the ray is parallel, then it will pass after reflection from F. Then third law, according to the third law, whenever the ray is passing through C, it will reflect in the same direction. So as you can see that both the reflected rays are meeting at A dash point. So here you can get the image of A point, that is A dash, and if you are extending this line, then you can get B dash. So as you can see, again real and inverted image is formed. So in this case, the position of the object is beyond C. You can get the image between C and F. As you can see, size AB object is large while A dash B dash image is small. So size is diminished. And type real and inverted. As you can see, these 2 points are rays are meeting in real. So real and inverted image will be formed. Next, third case, whenever the object is at C, as you can see that 2 rays are passing, so parallel, so it will come from F, and the ray will pass from F, that will be parallel to the main line. So image at C, position at C, same size. As you can see, AB object and A dash B dash, the size is same, and real and inverted image will be formed. As you can see, object AB is straight while its image A dash B dash is inverted. Fourth case we are talking about that whenever the object is between C and F. So as you can see, between C and F, AB object is there. So the ray is parallel to the principal line, then it will pass through F, and whenever it is passing through C, then it will be reflected in the same direction. These 2 rays will meet at point A dash, and you can get the image of A at A dash. So if we are talking about the position of the object, so it will between C and F, position of the image is beyond C, size is enlarged. As you can see, AB object is small but its size is enlarged, and real and inverted image will be formed because 2 reflected rays are meeting at one point in actual. Fifth case, whenever the object is at F, so as you can see the object AB is put on the F, so whenever it is parallel to the principal line, it will pass through the F, and whenever it is passing through the C, then it will be reflected through C. So as you can see that these 2 rays are not meeting in actual, but it will meet at infinite distance. So we can say that these 2 rays will be meeting at infinite distance, so the image of point A will be formed at infinite distance. So position of the image will be at infinity. And as you can say that A point is meeting at the infinite distance, so the size of the image will be highly enlarged, and type real and inverted image will be formed. And last case, whenever the object is between F and P, as you can see that AB object is between F and P. So third law, whenever the ray is passing from C, then reflected ray will be in same direction. And fourth law, whenever the ray is passing at P with some angle, then it will be reflected at the same angle. Now as you can see, these 2 reflected rays are not meeting at point, but if we are extending in backward direction, it will meet at point A dash. So position of the object is between F and P. Image that will be behind mirror enlarged. As you can see, the AB object is small, but A dash B dash, its image is enlarged. And virtual and erect. Why virtual? Because we are getting behind the mirror, and erect. As you can see that AB object is small, but A dash B dash image is large and it is erect. I think all of you are clear about this. Thank you very much.